Yeah,
Hmm.
here we are talking about what is groundwater. Actually, I mean, when the precipitation falls on the any type of precipitation falls on the Earth's surface, majority of the precipitation will go as a surface runoff, but but some quantity of the precipitation will infiltrate and then percolate into the subsurface data. Infiltrate at the surface and percolation in the subsurface, and deep percolation in the deep subsurface. See here most of the quantity will go as a runoff, and how much quantity will go as a runoff, that is based upon the infiltration losses. I mean, you can determine the runoff as like Rm minus pi into delta t, or rainfall minus initial abstraction into delta t. You can determine the runoff based upon that. But um, here that pi index, the losses are considered as the infiltration, the evapotranspiration, all the things are considered as a um, yeah, the part will be infiltrated and percolated into the groundwater and joins the water table. All the subsurface water that fills the pores, fractures, and other spaces in the rock strata in the saturated zone of the geological formation. Groundwater is available almost everywhere below the Earth's surface, though the quantity varies. Here I am talking about the unsaturated zone and as well as the saturated zone. In unsaturated zone, there are three zones: soil zone, intermediate zone, and capillary zone. Capillary zone is due to the capillary action. I mean, when there is some water table, due to the cohesion and adhesion forces, the water will rise. The water will be having some potential to rise. When there is some clay particle, it will the rise will be more. When there is some gravel particle or sand, whatever, the rise will be small compared to the clay due to the cohesion and the adhesion. In the soil zone is between the ground surface and below the, I mean, root zone. The It is known as the soil zone. Intermediate zone is intermediate between the soil zone as well as the capillary zone. And the, I mean, in this unsaturated zone, you have the three phases: air, solid, liquid. But in saturated zone, you have only two phases: solid as well as the liquid. That's all. And here if you see the water table, here there is, I mean, if you, it is analogy to the open channel flow. In open channel flow, the atmosphere pressure will be zero. Here also, on the water table, the pressure will be zero on the surface. As the depth increases, the pressure will increase in the surface water, I mean open channel, as well as in the unconfined aquifer. This is unconfined aquifer. um, the pressure will increase with respect to depth until the impervious zone. Yeah. While, I mean, here the pressure is zero and pressure is increasing with downward, the pressure will, the negative pressure will increase in upward. Actually, see here, you can see the logarithmic variation in the pressure. Actually, in types of water, here we have the gravitational water, capillary water, as well as the hygroscopic water. Hygroscopic water means, in the Greenham's equation, you must have studied about the residual water content. That is known as the hygroscopic water. Sorry, there is spelling mistake. Yeah. Uh, here the water will rise naturally, but here it is negative pressure. If you want to remove the gravitational water from this type of zone, it requires the minus 1 by 3 bar. 1 bar is equal to 1 into 10 power 5 Newton per meter square. It requires that much pressure to remove the water, to remove the gravitational water in the unsaturated zone. But while in capillary zone, it will require minus 1 by 3 to minus 31 bar. In hygroscopic water, I mean, in hygroscopic water, requires minus 10,000 bars. You cannot remove actually, so that people will depend on the groundwater, not unsaturated, the water contained in the unsaturated zone. Actually, the root water uptake also depends upon in this zone. I mean, some roots will go into the water table. There are very less, but most of the roots will be present in the unsaturated zone. Yeah. Here, Here you can see the how the groundwater flow direction is taking place. Here there is the head is more, the elevation as well as the pressure head is more. Here the elevation is low and almost the same pressure head, but the elevation head is more here. So water will go from high pressure to low pressure area. So the water will move from, the water table is also is above the this wetland. See, you can see the water table is above the wetland somewhat. So some of the water can contribute, the some of the groundwater can contribute into the wetland, and from wetland again it is going to groundwater. There is some mixing is taking place. This is known as the hyperphoic zone. There is some sort of mixing. Again it is going as a spring, again it is going as to groundwater, again it is going to some lake. From high pressure head to some low pressure head, the water is moving, the groundwater is moving. Water bearing formations, aquifer, aquiclude. These are different types of the water bearing formations you will be observing from the lithologs. From the lithologs you will be having the more clear idea. Aquifer is like, see here, this is the aquifer. Here there is the pores. There are large size of pores. Though they have the pores, but they have the interconnectivity also to flow the water particles from one place to another place. It is known as the aquifer. But aquiclude, like it is like clay. It will be having more pores, but less interconnectivity between the pores. That is known as a clay. Aquitard, it is sandy clay. It is somewhat permeable and somewhat acts as a aquiclude. It can act as sometimes it can act as a leaky aquifer also. Actifuge, it is like granite, solid substance, which doesn't have any pore, any interconnectivity between the pores, nothing. It is like solid, massive granite. These are the types of aquifer: confined aquifer, unconfined aquifer, leaky aquifer, multi-layered leaky aquifer. Yeah, while coming to confined aquifer, it is a confined between two impervious strata. Suppose think this is the clay and think this is the clay. It is analogy to pipe flow. It is impermeable, there is water here. So the pressure distribution will be parabolic. At the boundaries of the pipe, the pressure will be 0. At center, the pressure will be maximum. It is analogy to pipe flow. But in unconfined aquifer, it is analogous to the open channel flow. The pressure will be 0 at the surface, and it will increase. As they increase, the pressure will increase. The confined aquifer may become unconfined aquifer when the water actually here there is a water. Suppose consider the water level has fallen from here to some here in the middle. So at that time the water here it will behave as a atmospheric. The pressure will be 0 here in the middle. When the water falls down from top surface of the pipe to middle surface. But unconfined aquifer may act as a unconfined aquifer when the thickness of the water, thickness of the saturated zone is very high. Then the if you try to insert a borehole, the water will rise like anything. Here in confined aquifer, there will be lot of pressure in the middle, so that if you insert some borehole into that, sometimes you will be observing the water is rising to higher heights. It is known as an artesian well. Yeah, in the leaky aquifer, see here the water level is, the regional water level is here, and this is the hydraulic head inserted in the confined aquifer. This is the impermeable, this is confined, and this is unconfined. Here the water table is there. The water level in the confined aquifer, the water level in the unconfined aquifer, the water level in unconfined aquifer is low compared to the confined aquifer. So the water is rising like this,
there is some sort of leakage from this aquifer to this aquifer upwards. When see here the water level in the confined aquifer is low compared to the water table in the unconfined aquifer. So the water, some of sort of the leakage will be happening from this aquifer to this aquifer. And this is a multi-layer aquifer, aquitod. You can see, you can classify here. This is unconfined. This is some sort of leaky aquifer because it is aquitod. Aquitod is sandy clay. Aquifer is sandstone or sand, gravel, anything like that. And aquifer again, this type of thing. See here, it is unconfined, leaky, confined. Okay, and this is multi-layer leaky aquifer total as per the geology. Aquifer properties. There are certain properties, storage properties and transmitting properties. While go to storage properties, porosity. The porosity is the ratio of the volume of the void to the total volume. But the effective porosity is the volume of the interconnected void to the total volume. The effective porosity is less than the overall total porosity. We know that clay has the large number of porosity, more porosity, but sand has a very less porosity. But here, while coming to effective porosity, clay has the less effective porosity because in the clay there will be no interconnectivity between the voids, but in sand there is higher interconnectivity between the voids, so that the effective porosity is higher in the sand, lesser in the clay. While coming to specific yield, when you insert some borehole into the unconfined aquifer, there will be some sort of drainage will be coming into the well. Some sort of drainage will be coming into the well due to the gravity. It is known as a specific yield. Suppose in an unconfined aquifer, the water released from the storage is mainly due to gravity drainage and not due to compressibility of the aquifer material or of the expansion of the water. Volume of it is a specific yield is determined by volume of the water released per unit area of the aquifer per unit decline in the water table is known as a specific yield. This specific yield specifically used for the unconfined aquifer. The specific yield is the storage property of the unconfined aquifer, that is fixed. You should not use this specific yield for the confined aquifer, only for the unconfined aquifer, because due to the gravity drainage is taking place in the specific yield. That's why. But in storage, in confined aquifer, there will be more pressure, so that the water will rise. Like it is again, due to high pressure, the water will rise, but there will be certain gravity, but more pressure will be there. Storativity. This storativity can be used in the confined aquifer, but specific yield only used for the unconfined aquifer. The specific yield ranges from 0.1 to 0.3. The storativity. While coming to this definition, the volume of the water released per unit area per unit decline in the hydraulic head. You should not confuse here. The volume of the water released per unit area of the aquifer per unit decline in the water table. Water table does not have that much pressure compared to the confined. The story in it is the hydraulic head, it is the water table here. You should not confuse in between these things. The difference between the hydraulic head will be equal to pressure head plus elevation head. Here the pressure head will be small, but elevation head will be large. Here the pressure head will be large, elevation head will be small. That you should not confuse here. Here the water is released due to the compressibility of the aquifer and the expansion of the water. And the storativity ranges from 5 into 10 power minus 3 to 5 into 10 power minus 5. See here. Here the you cannot pump water easily from the confined aquifer due to the if you want to pump from the confined aquifer, you should do the compressibility. You should compress and you can expand the water, and then the pore water pressure decreases in the confined aquifer. If you draw lot of water, then it will, the aquifer will try to subsidence. The land subsidence may happen when you push more amount of water. I mean, some lakhs of water, volume of water put, you will be, there will be some sort of land subsidence will be taking place in the, due to this compressibility and the expansion of the water. I mean, actually the bearing material, the aquifer bearing material is the water and the soil. The soil will adjust when you push the water, because the pore water pressure decreases this. Yeah. Yeah, while coming to specific storage, the specific storage is also the property of the confined aquifer. The volume of the water that a unit volume of the aquifer releases from the storage under a unit decline in the hydraulic head. I mean, it is the volume of the water per unit area of the aquifer per unit storage. Per unit storage means area as well as the difference in the hydraulic head. That is it. But by here the SS will be is in the dimensions of the meter inverse. But specific yield and specific storage dimensionless. Here there are the two transmitting properties, that is the permeability or the hydraulic conductivity and the transmissivity. Permeability. The permeability, there is some sort of difference between the permeability and the transmissivity. When you say about the permeability, you will talk about the rate of flow of per cross-sectional area. If you take some soil sample, only for that soil sample only you will be able to talk about the permeability. But when you talk about transmissibility, it is whole for the aquifer, total aquifer. To determine the permeability, there are different types of tests. I mean, laboratory tests and the field tests. In laboratory tests, we know that constant head permeability and falling head permeability. The field test, pumping in and pumping out test, and slug test, and tracer test. Tracer means you will be adding some sort of chemical into the well, and you will be observing that type of the flow is taking place, whether the right direction or the left direction. There will be at some distance there will be some observatory well. You will be able to collect the sample and analyze how much time it has been taken from one point to other point, and the distance, you know the meter by time. You will be knowing the velocity, and I mean from the velocity the divided by permeability. I mean per unit hydraulic gradient you will be knowing the permeability. Transmissibility for the total aquifer, it is the rate of flow under the unit hydraulic gradient through a unit width of the aquifer thickness. Here T is equal to K into H. H is the thickness of the saturated zone in the unconfined aquifer. T is equal to K into B, confined aquifer. Here B is the thickness of the confined aquifer. Here H is the thickness of the saturated zone. You have to remember that. It is usually represents meter square per second and meter square per day. Yeah. When you select an aquifer, it should yield higher transmissibility. From large area, the water should come into the well. Not like suppose if you want to check the pumping test of the clay zone. In a clay there will be more storage, but there will be less flow will be taking place due to the less permeability. Due to that, there will be more amount of the drawdown you will be observing in the clay. See, like this more drawdown you will be observing. But when you pump from the sand zone, you will be observing a less drawdown, because more amount of water is coming from like this. Here the less amount of water is coming like this. You cannot see this type of aquifer. You should see this type of zones. When you do pumping tests and all, you will be observing more clearly about the cone of depression. See, when you start pumping, it is the shape has been like the depression is in the form of the three-dimensional cone. It is known as a cone of depression when only the pumping taking place. It is the initial water table. They consider that it is the initial water table. After pumping, this type of shape is occurring here, the difference between the this thing, the difference, the height, it is known as the drawdown. Sorry, it is known as the drawdown. And the radius of the influence, from what distance, I mean here, see here, here due to this pumping, there is no effect on the water table at the corners. It is the radius of the influence. It is large here, but it is very very small here. Hydraulic gradient, yeah, when there is a high slope, there will be less amount of water traveling with more amount of velocity. When there is a low slope, there will be more amount of water traveling with less velocity. That is the hydraulic, it represents the hydraulic gradient. We should recognize the hydraulic gradient should be low and the hydraulic conductivity should be high. Here it is low. Under drawdown, I mentioned discharge. Here you can get the water with high pumping discharge, but here very low. We should see the alluvium aquifer. Here the hard rock aquifer is acting like on the well station. Yeah, while coming to Darcy-law, it is the most governing equation in the groundwater. Where here see what Darcy said, that means there is some flow is happening from here to this cross sectional area. When the flow will happen, when there is some head difference, when there is some head difference only the flow will happen. If the head difference is zero, it is not, I mean nothing flow will happen. There is some hydrostatic pressure will be happening there. So I mean when there is some difference in the pressure head only, the flow will be taking place here. Pressure head means, I mean the hydraulic head means the pressure head plus elevation head, both. The rate of flow per unit cross sectional area, see here the rate of flow per unit cross sectional area, so that only we are talking about the permeability, is directly proportional to head loss and inversely proportional to the length of the sample over the head loss occurs. The discharge directly proportional to head loss and 1 by delta, I mean inversely proportional to the length of the sample, and Q is directly proportional to area. Yeah. Assumptions of the Darcy-law: the total sample should be saturated, and the flow through is considered as a laminar. I mean very low velocity here. You cannot consider turbulent. Suppose in our region in Telangana or Andhra Pradesh, it is totally hard rock region. You will be observing some limestone caves, carbonate caves or the limestone caves, whatever, and the dolomite caves. At this area, the Darcy-law will not applicable. See some in as our hard rock zone, there will be some large amount of fractures. At that time also, there are some assumptions to consider, but there are some cases where the Darcy-law is not applicable in the hard rock regions. It will be more applicable to the alluvium regions. Steady state flow, yeah, and the total considered okay. This is the total discharge. Q is equal to, this is the velocity of the Darcy-law, minus k into dh by dl into area, and the Darcy flux. Q is equal to minus k into dh by dl. C pi velocity minus k by Ne. Ne is the effective porosity here into dh by dl. Applicability of the Darcy-law: it describes a linear relationship between the specific discharge and the hydraulic gradient. However, as the flow rate approaches to zero, or when the high rate of flow, I mean like I said, fractures are the cast features. I mean cast features means the limestone caves. Flow, I mean limestone caves means why limestone will form the caves means due to dissolution, due to the water, the carbonate and the carbonate present in the aquifer and the water will react and will soluble due to water. That is the thing. I mean there is a large amount of hole will be forming there, so that it is a cast feature. Flow may not be linear there. It like turbulent there. The Darcy-law does not appropriately represent the groundwater flow there. The Darcy-law as presented here is not valid for the compressible. See, suppose temperature changes or the liquid property, like if the oil is present in the groundwater flow, there the Darcy-law will not be valid there, because due to the changes in the viscosity and temperature. The Darcy law is not applicable if the density of the fluid varies due to differing pressure, temperature, and the high concentration of the dissolved gas excellent. Yeah, when you say about the groundwater flow net analysis, you need to know the main important thing is that when you construct the flow net, Darcy law is valid. You should check that whether the Darcy law is valid in your region or not. Hydraulic conductivity of the material is said to be homogeneous and isotropic. I will say the next slide about homogeneous and isotropic. Material is fully saturated. Flow is steady. Fluid has a constant density and viscosity. Vertical and the horizontal axis are drawn to scale. Okay. Yeah, I mean, actually, when you draw the, before drawing the flow net, um, the groundwater level which you have, in India, which you have will be in the meter below ground level. There is some sort of difference in the groundwater level and the groundwater table. Groundwater level is the meter below ground level. The groundwater table is the meter above mean sea level. That you should think about it. You have to determine that from the groundwater level. You should not confuse between the groundwater level and the groundwater table. See here there is a river and the groundwater is flowing into the river because it is a gaining stream. When it is reverse, it is a losing stream. See here it is not the meter below ground level, it is meter above mean sea level. This 140 meter, 130 meter, 111, these are all the groundwater table, not groundwater level. Okay, yeah, you here they have drawn the equipotential lines at 10 meter spacing. They have drawn the equipotential line. Take one study area, take as well as your area, and you will be having some observed well data, and separate that meter below ground level with elevation. You will be having the groundwater level at spatially with you, and do kriging or the IDW for the whole area, and try to plot the contour. That is the equipotential line that you will be knowing. Yeah, after that, after creating the equipotential line, try to draw the flow line. The equipotential, the water will move from higher higher water table to lower water table. Here the river water surface elevation is low compared to the groundwater table. Here the river, see, yeah, here also the water surface elevation is low compared to the water table here. So that due to the difference in the head, due to the gravity, the water table, there was some amount of the water contribution towards the groundwater into the surface water, like this. If you do for your area, you will be having the whole idea how the groundwater motion is taking place, from which area, from which in which direction the groundwater flow is taking place, and you will be knowing the response of the river with respect to time. Suppose in 2000 most of the rivers are perennial, but nowadays maximum rivers are gaining, losing their perenniality due to the more amount of groundwater extraction. So that the groundwater table is declining, so that the water surface elevation is higher nowadays compared to the groundwater table. So that due to the head difference from the river to water table, the water will go like down. There it is a losing stream. Many of them are losing their perenniality and whatever. Yeah. Here, yeah, if you see here, this is a very non-linear topography actually. Very complex topography too. This is the highest position of the water table. There are two directions. Here there is some tank, whatever. Here there is some tank. The water, due to the head difference, the water directions will go from here to here, and here to here, and here to here. And due to some head difference, the water will move the here from here to here, whatever. Yeah, okay. I mean, compared to here, there will be some sort of recharge so that the water is coming here and to here. This is known as a local flow. I mean, when the water is recharging from here to some sort of distance, the water body to, it is known as a local flow. But here, the water is going to larger areas. The distribution is larger actually, so that it is known as a regional flow system. You don't. I mean, you have to look into it very in a deeper manner. You will understand about that. Yeah, the same sort of the this is. I mean, from here to here, the water is movement is taking place. From here to here, this is known as a local flow. From here to here, the water is taking place. It is known as intermediate flow. From here to here, this total region is flowing. It is known as a regional flow. Suppose here in the gradient, I mean how the flow will change based upon the gradient. Take the coarse sand here. When you take the whole coarse sand, the you know that the flow is taking place from here to here. There will be somewhat less hydraulic gradient. I mean, sorry, yeah, less hydraulic gradient due to the I mean less pressure drop. But here, as the uh, here because I mean here there is more amount of interconnectivity. As the interconnectivity decreases to fine sand, the pressure drop increases. Pressure drop here to here it increases. I mean head difference. Yeah. While coming to here, the fine sand when Q1 is greater than Q2, both are the same sort of sand. Q1 is greater. I mean, so that I mean when the Q1 is greater, there will be more amount of the pressure head, and velocity will be same here. But here the Q2 is very less. There will be less amount of the pressure head, but the velocity will be same. Yeah. Here the A1 less than A2. Here the cross sectional area is changed. I mean when you press the pipe, the I mean the water. Suppose there is a pipe, the water is flowing. When you press the pipe, the velocity of the water inside the pipe will be very more. I mean discharge is same, of course. The discharge will be same, but the velocity will be very high. But here the A2 is very low. Here, I mean, you have been released, so that the velocity will be very low. There will be more pressure. I mean, here there will be, as the A1 is larger. Here there will be more pressure, but as the A2 is larger, here there will be sorry, A1 is less. Here there will be more velocity, less pressure. A1 is less than A2. I mean, A2 is greater. If the A2 is greater, yeah, the pressure drop will be very less. Okay. A1 is less than A2. The discharge, okay. Pressure, here is pressure. What happened? Okay, I will come it to it later. I will come this that point to it. Yeah, here the flow is taking place from the high in this direction. Here there is some inflow of the 0.2 meter cube per second. This is the no flow boundary. The black line. I mean, you can see that. The dashed line or the no flow boundary. These are the no flow boundaries, and this is the no flow boundary. Here, there is a head of the 1000 meters. Here there is a head of the 10 meters. Here there was some low permeability zone. See how the flow lines is behaving. The flow lines are converging here. When you come here, the flow lines are diverging here. I mean, you can see the variation. When you come here, the sand and the fine sand. Here there the permeability is very more. Here the permeability is very less compared to here. When the permeability is very less, the I mean I said now when you hold the pipe with hand, the water will be moving very fastly. Here, see here, the water will be moving very fastly. The pressure head decreases because to maintain the law of conservation of energy, the Bernoulli's equation, you know that when the pressure head increases, the velocity head decreases. When the velocity head decreases, the pressure head increases. Like that. I mean, this is solving that equation actually. Yeah, here also the same thing. The cross sectional area is changed here. A1, A2. Okay. When it goes to the less cross sectional area, the velocity increases here, so that the pressure decreases here. It is happening like this. Okay. While coming to the isotropic and homogeneous, isotropic is in each and every direction the property of the medium will be same. In homogeneous, at every place in the same direction the property will be same. Anisotropy in every direction, you can see here anisotropy and homogeneous. See here the ky and here the it is having different permeability in different direction, but homogeneous. In isotropy and homogeneous, here you will be in each and every direction the same permeability, but at different places different permeability. It is anisotropy. I'm sorry, heterogeneous. Uh, in each and every direction the property is same, but at every place it is not equal. Anisotropic and heterogeneous. I mean, at every place the permeability will not be equal. In each and every direction the permeability will not be equal. Yeah. While coming to here, A1, I mean A2 is more greater. Then there will be more amount of flow is taking place and less pressure here. But here A1 is lesser, so there will be more amount of loss will be taking place here. That's the thing. That's the thing I want to say here. Yeah. Thank you.
Okay, Prashant.
If you have any doubts, tell me.